Welcome to Design, Build, and Deliver with Hart Companies, where we dive deep into the world of life science with leaders who decide, design, and deliver the next generation of pharma and biotech facilities. I'm your host, Samir Gondalia. Thanks for joining me as I interview visionary leaders shaping biotech and pharma facilities from C suite executives to project decision makers. Hear real stories, industry trends, and actionable insights to help you build your facilities and your career smarter, faster, and better. Let's continue with Design, Build, and Deliver with Hart Companies. My guest in this episode is Michael Kelly. Michael is the Director of Bioprocess Engineering at Hart Design Group, where he has been leading innovative process solutions with a career spanning top-tier biotech and engineering firms like Parsons Corporation, Biogen, Amgen, and Moderna. Mike has held increasingly senior roles across engineering, project management, and facilities operations. He has a degree in chemical engineering from Widener University and an MBA from Bentley University. He brings technical acumen along with strategic thinking, which were abundantly clear in this interview. Michael enjoys traveling, ice hockey, golf, and a good book. In this chat, Mike and I discussed the evolving landscape of the pharmaceutical industry, the facility retrofitting, and the integration of new technologies, the importance of flexibility in facility design, the role of innovative tools like 3D scanning and augmented reality, and the challenges of managing operations during retrofitting. Additionally, we highlight underrated causes of project delays and provide insights on how life science companies can choose the right engineering partners to ensure successful project execution. I enjoyed my chat with Mike a lot. I hope you do too. Here's Michael Kelly. Good morning, Mike. How are you doing today?
Doing great, Samir. Thank you for having me.
Thank you for joining us. Really appreciate you joining us and sharing what you're going to share with us. Let's start with something very pressing in our industry, pharmaceutical industry. 2025, last couple of years, we know that the capital budget is a little scarce. It's not as generous as it used to be. But we still need work to do. We still have projects. We still have facilities to maintain and upgrade. In old times, we just used to build a new facility. If something reached its timeline, then we'd say that, all right, it's time to build a new one. A lot of companies right now are looking to retrofit the old facilities instead of just building a new facility because of all the reasons. If you had to look at a facility and if you were to answer that, should this facility be torn apart and build a new one or retrofit, how would you go about making that decision?
Yeah, we're seeing some of both right now. Some of the larger companies are moving towards newer buildings. However, we are seeing more and more clients working on the retrofit side of things. They're trying to maximize the space and the buildings that they have today. But some key components to take into consideration is really structurally, can the building handle the new equipment, the new additions, and other pieces that they're looking to fit into an existing footprint. We've seen maximizing space, larger equipment, heavier equipment is really putting strain on some of these existing buildings, especially the older facilities that have been around for a while. In addition, one key component to look at is the existing utility system, in particular HVAC, electrical, plumbing, etc. And has future capacity been identified in the past? And will those utility systems be adequate for this new construction? In addition to that is your waste streams. We're seeing larger and larger waste streams as we increase the capacity, flow rates, things of that nature. So the waste streams need to be taken into consideration as well. Lastly is really the space itself. Again, as equipment gets larger, as more and more filter membranes get added, the space becomes more and more congested. So really taking into consideration the space constraints and having enough free space for manufacturing operators to operate this new equipment and not trip over hoses, themselves, new equipment, and really ensuring there's enough allocation for that open space for movement of equipment. It all comes down to time and money, really.
Right, right.
So again, retrofitting is a faster option. There are tools that we use consistently to assist our retrofitting, and basically we've been using a lot of technology to assist in the retrofitting.
If I can add one more thing, Mike, to what you already mentioned, the topics and points to decide about retrofitting. I think what you and I were talking about, I think few days back, the companies are also looking for flexibility. It's not like, okay, you are building a facility for MAB, you're going to be doing MAB, right? Because the modalities are changing. So now companies are building facilities where you can switch between MAB or cell and gene therapy, or potentially can turn it into HPAPIs for high potency or mRNA. They want that flexibility too. And different facilities have different utility requirements. So to point, you mentioned a point about utilities and layout. I think that's one more thing that we have to consider about flexibility for different modalities, and some of their modalities that we don't even know about yet, which will come handy after 5-10 years.
Yeah, absolutely. We're seeing more and more products trying to be run through the same facility. Not all of them use the same equipment. So
Right.
we're looking for a lot of different flexibility through transfer panels and mobile equipment and portable equipment to essentially mix and match and really make the facility as flexible as possible. We're also seeing a large combination of stainless steel and single use mixed together, and not necessarily one or the other anymore. So again, that allows that flexibility to maximize the space and maximize how many products can run through a facility.
Absolutely. Now let's get back to what you were talking about, the new tools and technology we use for retrofitting, because there has been an evolution of new tools. Everybody knows about AI and ChatGPT and other technology out there. We do have comparable, if not similar, new tools available, which we didn't use 10-15 years ago, but now they're part of at least good engineering and design firms use these tools.
Yeah, absolutely. We start off the old school way, right? Typical walk downs in the facility, assuring that the documentation that we're given at the beginning of a project is accurate, and ensuring, connection points are where they're stated on the 2D drawing. We then take that one step further, and we've been using a 3D scanning technology, which we can go into an existing facility, very quickly scan the facility in a 3D manner. We then bring that back to our office and piece it together and essentially have a virtual snapshot of the existing facility, which we can then walk through on our computers here in the office. We could take measurements from it. We can walk through and scroll around it. But where we use it the most is we're able to turn it on as a layer into our 3D modeling. So when we're doing our 3D modeling of the new scope of work, we're able to turn that scan on to ensure that we're not clashing with the existing conditions. We're making sure that we have enough space to put new equipment, have maintenance access, things of that nature. We're also able to put the 3D scanner onto large stands and, really scan into areas that aren't readily accessible if you're doing walkthroughs in the facility. So we've been using that very successfully. And again, it is a very important part of all of our retrofit jobs.
What would be some of the real life examples of using these tools? Let's say you have a facility with tanks and pipes and all those things, and you're doing X work and you use this 3D scanning. What would be like real life examples of using this?
Yeah, great question. So we've dealt with it on quite a few customers. I'll say the first example that comes to my mind is bringing in large pieces of equipment, large tanks, things of that nature. And so we use the 3D scanning along with our 3D modeling. And then we also have a third technology that we use that's augment, and you basically look through a headset and you can see the existing conditions and also bring in pieces of the model. And so we use this most effectively for rigging in large pieces of equipment. to ensure that we are not clashing with existing conditions. And we can basically step that through with the client, with the construction team, to really show this is the way we're going to bring a large piece of equipment into your facility. We show them that we're not going to disrupt anything that's existing. And we really use it to assist in our rigging plans to show which direction we want to come in, where we need to make turns, and then essentially how are we going to stand up this equipment in the field.
Right. So it seems that, let's say we are bringing in a tank which is, say, bigger than the door or a window, and you want to bring in, if you do this 3D scanning, you can virtually see whether you can even get the equipment or a tank through the door. If not, if you have to knock over a wall, what size hole to dig to, which path to take so it wouldn't knock over pipes and all those things. So it wouldn't do any disruptions to existing facility. Did I get this right?
Yeah, that's exactly correct. It also helps us with our pre-planning, right? So if we need to remove a utility line out of the way or some duct work, we're able to identify that early on before the equipment shows up on site. We're able to move that out of the way to ensure when the equipment does arrive on site that it comes into the building smoothly, and we're able to rig it into place without any problems.
Yeah, that's very, very important, because as we talked about, a lot of retrofitting work that we see is done with the existing manufacturing going on. It's not like you can, first of all, it takes a lot of time and energy to shut down a facility and bring it up. You need to start all the equipment on all of that again. And if it's a commercial manufacturing facility, there is loss of revenue. So a lot of the preference would be you continue to do your work while you do this sort of retrofitting or upgradation. What's the best way to make a GMP or facility retrofit or upgradation while you have the manufacturing or any other GMP operations going on in that particular suite? Because for the most part, they use common HVAC system, if nothing else. Physically, you can separate, although that's a challenge too, but the environment, and you need to maintain the environment. So how would you go about making changes to the existing GMP manufacturing facility without stopping that GMP work?
Yeah, absolutely. We're being asked to do that more and more to limit the durations of shutdowns or just to avoid them altogether. Again, these facilities are becoming more and more used, and the clients need to continue to produce product with rolling shutdowns or, like I said, a limited shutdown. So what we've seen lately is phase construction and really approaching that from that point of view as you're designing it. So we're putting together phase design packages even to break those up into smaller pieces and have those roll into the phase construction plans. And so we can maintain a shorter schedule and really get the design packages out to the field as soon as possible so that they can begin their work. The other piece we've been using a lot with our construction team is access. How do we get access to these areas without disrupting GMP conditions? Also, not necessarily entering the area until absolutely necessary. So we've been getting very creative with scaffolding and other means and methods on how do we execute as much work as possible outside of the GMP bubble to be ready once we do get that go ahead and that green light to go ahead and get in there and take care of the work inside the GMP. We've also done quite a few different tenting strategies, things of that nature, as you mentioned, Samir, bringing down specific areas and making them into gray spaces while areas around us are still manufacturing. So that really feeds into the phased approach as well. The other piece we're looking at is utility tie-in points. So really running calculations, looking at each of the existing lines to see what would be the least disruptive shutdown and still have the capacity that we need to run the new systems and the existing systems. So not just tapping off the header every time because that's the easiest and closest location, really looking at alternative locations to limit the disruption and the impact to the client. The other piece we're really looking at is the more and more items that we add into these facilities, it's getting tighter and tighter and tighter. And so I go back to rigging new pieces of equipment into the facility around existing equipment, existing conditions. And so again, we've been working very closely with our third-party vendors that are manufacturing skids to make sure that we have the right shipping splits, we have the right dimensions identified up front, so that we're able to successfully bring this up into pieces and then essentially put it back together once it's in place. So we're seeing more and more in that to limit how many doors we need to replace, or bringing in larger rigging equipment into a facility that can't allow it. I think the biggest piece too that I'm taking away is logistics planning.
Right.
So
Right.
we 3D model everything. We verify in the field, with hard measurements. If we feel that we're too close for comfort, again, we use our augmented reality where we need it to ensure that we're not going to run into existing conditions and we can make this as smooth as possible. We also work hand in hand with our construction teams and the trades and, really get their buy-in up front as soon as we identify this, so that they're in the loop. They have a voice. We listen to their recommendations and really try to capture that at the design level before it's too late.
One follow-up question. How do we manage HVAC? So you have common HVAC for the whole suite and you are working, half the suite is, let's say, GMP. And the other is where you're doing constructions, you have dust and it's not GMP, right? How do you do HVAC? If you can explain from engineering point of view. This is just for my curiosity.
Yeah, absolutely. So there's a couple different ways you can do it. Sometimes you can very easily just shut certain dampers to isolate that space. Other times we turn sections down further just so the cascade is still there. The GMP is on the clean side and you're cascading into the gray space or the construction area.
One way of clean air.
Yeah, exactly. In other cases, we've had to make direct cuts into the ductwork. And so again, we just isolate the construction area as much as possible and then rebalance and make sure that the GMP facility is operating under the condition that it needs to.
Okay, that's great. Now, for projects like this, retrofitting and facility upgradation, and what are some underrated causes of delay? And I don't mean, equipment was delayed by 3 months because it was coming from a different country, but the causes just seem small, which can easily be fixed, but are overlooked, which causes delay for this type of projects because timeline is very tight. You are working on something that's already being done in a GMP facility. So what are some underrated causes of delay, which are easy to fix, but also very easy to overlook?
Yeah, we're seeing an industry trend of faster and faster design, faster and faster construction. This allows the clients to make project decisions as late as possible, but it does put, stress and pressure onto the design and construction teams. With that trend, I would say some underrated causes of delay is site conditions, right? Being on site, being in proximity to your clients, and really having that willingness to travel to the sites, meet with the clients directly face to face, conduct walk downs, do field measurements, and really proactively be there as much as possible. We especially do this during peak construction activities. We increase our site presence. We have put staff members on site full time to ensure that we're not having delays and we're answering questions and solutions as fast as possible. I think the other piece that we're seeing is different offices in different areas, as well as using multiple firms while doing different pieces of the designs. Uh, Here we do all engineering disciplines. We also have architects as well, all under the same roof in the same office. And really, that breaks down the silos. But more importantly, we're not waiting for one package to be released for the next person to do their work. So it's all done in parallel versus in series, which can allow us to really deliver these packages faster. I'd say the other piece that we're seeing more and more of is engineering firms and others bringing designs to a certain percentage and then handing it off. We're not that type of company. We really, you know, do our design from the lens of you can build this, you can procure from this, and really taking it all the way to the end there. So again, we provide all different packages from P&IDs through electrical drawings, GAs, elevation views, ISOs, etc. But I would say most importantly is our procurement package. We really provide accurate lists with quotes from local vendors, and we hand that off to the construction team to directly purchase from those instead of having them trying to figure out what we mean from a data sheet or a specification.
Yeah, I like that part where you said that having just one company with everything under one umbrella. And I'm going back to my project days. If you have different firms, you ask one firm about delay and they blame it on other firm, and then they blame it on another firm. And it takes you like 3 weeks before you find out the reason for delay. But if there is only one firm doing all of that, you have only one throat to choke. Ask one person and hold that person or that company rep accountable. So the theme of this talk is that to do projects faster, cheaper, and compliant. To that effect, life science companies, life science industry that work in, the companies are onboarding more and more engineering and design firms because they want options. If they have a project and if there is the urgency, and if their three favorite design firms can't work on the project, they still want to get the work done, not have to wait for their preferred design firm. So they are onboarding more and more design and engineering firms. What would you advise to a life science company how they should go about choosing their engineering and design firm partner? What are the things they should look for before they start working with a new company?
Yeah, absolutely. To touch on my last point, right? What disciplines do they have in-house? What are they outsourcing? And what does that mean for cost and schedule impacts? The other piece is capabilities, right? What are they going to be executing themselves versus handing over to the construction firms? Again, we do all our 3D modeling ourselves and hand that off to the construction firms versus some of our other engineering companies that, you know, hand it off at a different level. I think our biggest, you know, positive is creativity to solve problems and really able to react to unseen conditions. And really, as I mentioned before, going out in the field, seeing the source of the problem and coming up with a solution. More and more creativity that we need to use. A good example of that is how do we get into a construction area without having to go through the GMP area, right?
Right.
And so, you know, can we put an access door through a wall that, you know, maybe we weren't really thinking of cutting a huge hole in the wall. And so
Right.
again, that saves time on gowning and wipe downs and, you know, really lowers the risk of compliance in the GMP areas. So I think it's more than just your standard engineering packages. It's more of creative solutions, working with the clients directly and understanding their needs as well as the construction crews and what they need from their side. I think the other piece is, you know, we have in house too is a lot of capabilities for calculations, and we perform all that in house as well. So we do, you know, pipe flow, but a big component is arc flash. We do arc flash modeling. We're able to generate labels, and we do that for many customers. And again, we have their facility modeled out. So if they're adding new additions, it's very easy for us to update our model to capture those new pieces. I would say lastly is, as I mentioned before, is just cross-discipline coordination. Everybody's in-house. We talk to each other constantly. We're in the same room having breakout meetings. And again, we have a construction firm and a passivation firm downstairs. So we look for their input. We talk through solutions with them and really make sure everybody's on the same page with expectations on what's coming. Lastly, taking into account the trades. They do this day in and day out, and they have a lot of good ideas as well. So we want to make sure that we hear their voice and really take their feedback and see where we can input that into the design as well. A great example we had for that was we were planning on developing a skid that we were going to move into place, and we got their input that that's not the way to do it. That's going to cause more disruption. It's going to muddy the waters. And so really they talked us out of the skid option, and we went into a stick built option and worked through it with them and came up with a great solution on how we could do this stick built in the field.
Okay, so Mike, let's talk about you now. What are some of your favorite books that you keep going back to, or some good books that you have read lately?
Yeah, great question. Love books that are currently being turned into movies and TV shows. And I love identifying the differences and really just, that's not what happened in the book. And you always hear the book was so much better than the movie.
Yeah, I was gonna say that you seem like the type of person who the book was better.
Yeah, most of the time that's true. I would say my favorite books are basically from David Baldacci. I also like the Jack Reacher series from Lee Child. And, if we're being honest, I am a huge Harry Potter fan as well. Yeah.
If you have to give a TED talk about a topic outside of your technical expertise, what topic would you choose?
Yeah, staying along the theme of today, I think I would do a TED talk around building biotech facilities for the science that hasn't been invented yet. Really we're being very reactive to science right now, right? The processes are being developed and then construction reacts to that. And so I'd really like to try to flip that and proactively show future designs and considerations and strategies on, how do you build a facility for what's coming next down 5 years, 10 years, and really just bridge engineering visionaries all together to show how we can set the stage so that we don't have to go in and retroactively change these facilities, a year later, a day later, as science keeps evolving.
I think that would be a fascinating project, working with researchers at universities who are working on Petri dish and then extrapolating what the manufacturing process would look like when fully developed, what unit operations, utilities, and incorporating that in there. I'm sure there has to be a way to come up with like a common denominator facility parameters. You know what I mean? Like, okay, you need these 8 utilities and you need all these things. And once you have that, you should be able to manufacture probably like 90% of modalities at different platforms. So, Mike, this has been fascinating. If somebody wants to get in touch with you, what's the best way to get in touch with you for a question, collaboration, or just to say hello?
Yeah, there's 2 ways. I'm on LinkedIn, so that would be probably the easiest, is just reach out to me in a chat on LinkedIn. Or you can email me directly at mkelly, Kelly, at hartcompanies.com.
Okay, I'll put all of that in the show notes. Mike, thank you very much for sharing everything you did today. This was fascinating, and I'm sure our listeners would enjoy it too.
Perfect. Thank you, Samir.
Yeah, thanks, Mike. Enjoy the rest of your day.
Thank you.
Thanks for joining us on Design, Build, and Deliver with Hart Companies, where we explore the people, projects, and ideas shaping the future of life science facilities. If you enjoyed this conversation, be sure to follow or subscribe so you don't miss upcoming episodes with more leaders from across the biotech and pharma world. To learn more about Hart Companies, our integrated design, engineering, and passivation services. Visit hartcompanies.com, that is HART companies.com, or connect with us on LinkedIn. I'm Samir Gondalia. On behalf of everyone at Hart, thanks for listening. Until next time, build with purpose, deliver with pride.